We will study the implementation of PWM pulse width modulation using ATmega328p on motor DC motor using motor driver. Uh, Here we study that two modes of the PWM. One is fast and second is the phase correct PWM. Here is a graph of fast pulse width modulation, and here is a phase correct pulse width modulation. And the difference is that in fast PWM, when the signal go to the peak, it reverts immediately to the initial position, and in phase correct, it slowly goes down to to its initial position as it goes to the peak. Here are the timer modes. When the timer mode WGM is 000, it shows timer mode will be normal. And similarly, when 001 is phase correct mode, when 010 then CTC mode. Similarly, these are the modes for the PWM. Now here is the first task. In this task, we use the basic purpose is to control the PWM of LED. We control the brightness of the LED using PWM. Here we define the CPU 16 megahertz, and here from here starts the main program. Here we set the OC0A as output, and set OC0A OCR0A is equal to 0x7f. Here in timer counter, we set the fast PWM for 50% duty cycle, and here we set the n is equal to 0, which means the no prescaler. Here we use the while loop. Here we start from 0 and goes to 175 with the increment of 1, and here we set the delay of 100 microsecond. Now we go to the simulation. Here is a LED. Code is already uploaded. Now we start the simulation here. Now we can see that the LED is dim. Now slowly it goes bright. The brightness is increased. Now we move forward. Now our next task is to control the motor speed using PWM. Similarly, we define the CPUs as 16 megahertz. Here is the input output header file. Here is the interrupt header file, delay header file, and here from here we start the main code. In first line DDR D0xFF, we can configure the port D as output. It shows the all port D as high, and here we send the 0xFF at port D, so the all the interrupts pin will be high initially. So in the next line DDRB, we will sending 1 at PWM pin IE OCO0. Here we call the external interrupt, and here after this in timer counter 0b we set the n is equal to 1, which means the no prescaler. And here we call the interrupt using SCI command. Here we use the while loop. Here we create the four situation duty cycles. First we change accordingly with the in the simulation with the buttons. With duty cycle 0, duty cycle 80, duty cycle 140, and with duty cycle 210. And now here next is the simulation. We go to the simulation here. Now we run the simulation. Now we can check the PWM here. Here is a condition of, we can see here the duty cycle 0. The next condition is the duty cycle 80. Now next is greater than 80, and next is faster. Next for the simulation. Now we go to the hardware.